For our first one, for a math talk on exponent rules, we're going to rewrite each expression as a power of 2. Now, if you look, if I were to expand this and write 2 to the third, that would equal 2 times 2 times 2. And then I'm multiplying that by 2 to the fourth, which would equal 2 times 2 times 2 times 2. But then if I were to rewrite that in expanded form, this would be 2 to the 1, 2, 3, 4, 5, 6, 7th power. And similarly, if I did 2 to the 5 to the second power, or times 2, so I would have multiplying 5 2's and then times another 2. This would be 2 to the 1, 2, 3, 4, 5, 6th power. Now, what you might wonder is, did we need to really expand that to write that in that manner? Is there a relationship between the 3 and the 4 and the 5, and this would be 2 to the first power because you're not seeing it. And you might notice that in the exponent, 3 plus 4 is 7, and here 5 plus 1 is 6. So when you multiply exponents with the same base, when you multiply numbers with the same base, you add the exponents. So again, when you multiply numbers with the same base, you add the exponents. Now, some of you may be very happy to write that rule out in words, but what you can do is just say a to the n power times a to the m power is equal to a to the n plus m. And what you notice here is we have the same base, and then you just add the exponents. Similarly here, when you divide, we're going to look for relationships there. So here, this would be 2 to the 10th. So I'm just going to multiply 10 2. So 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. And then divide that by 7 2. So 1, 2, 3, 4, 5, 6, and 7. And what I want you to remember is 2 divided by 2 makes 1. So here's 1, another 1, another 1, another 1. And all of those, and this is what we call canceling out. So this would really equal 2 to the third power. Similarly, if we did 2 to the 9th, so I could just write 9 2's up here. And then divide that also by 2. That would make 1. And this would be 2 to the 1, 2, 3, 4, 5, 6, 7, 8. And what I want you to notice is there a relationship between 10 and 7 that makes 3, and 9 and 1 that makes 8. And what you might have noticed is, yeah, you could subtract. 10 minus 7 is 3, and 9 minus 1 is 8. So again, when you multiply or when you divide numbers with the same base, subtract the exponents. So here, this would just say a to the m divided by a to the n equals a to the m in the numerator minus n. So I was a fan when I was a student of just the symbolic notation because I didn't like writing all of that out. So make sure that you're comfortable with both. Can you explain what the symbolic notation means in words and vice versa?